This is the 2026 senior project for Team 23, the MillerKnoll Fabric Spreader and Tracker. Before diving into the project, let's meet the engineers. Team Captain Jack Doxey, Bailey Birdsall, Tyler Coker, Emmett Top, and Grant Feaster. The current fabric cutting process at MillerKnoll begins with the operator manually loading a roll of fabric onto the machine. Once the roll is in place, the operator pulls the fabric across the table and positions it at the required length. After the fabric has been spread, a smoothing stick is used to remove wrinkles and ensure the material is flat and properly aligned. The operator then cycles the cutter to complete the cut before repeating the process for the next piece of fabric. The existing process has several known issues. First, the remaining roll is virtually unknown after the fabric is cut, relying on the operator to physically weigh the roll to estimate remaining fabric. The process also relies on a complex cut ticket that provides little to no verification of the actual fabric type being used. Additionally, the visual estimation of cut lengths creates a greater chance of operator error. The current system can also present ergonomic challenges for the operator in carrying heavy rolls and reaching over the machine. For the scope of our project, we focus on addressing three primary issues: the unknown remaining fabric length, the high potential of operator error, and the lack of accurate, repeatable cut length measurements. As previously suggested, the current system involves the operator weighing the fabric roll on a scale before it being returned to inventory. This process has shown to be inaccurate in measuring the remaining fabric on the roll, as fabric type, weight per square unit, cardboard spool size, weight, and length in sig figs all contribute to erroneous measurements. All of these factors decrease the system accuracy and can compound and add to the machine cycle time. In the current process, the operator uses a long measuring tape attached to the edge of the cutting table to determine the distance of each cut. This requires the operator to estimate, or rather eyeball, the cut length, which can lead to inaccurate cuts, increasing the amount of fabric wasted. The single greatest issue that was encountered within this project was the variability in fabric from cut to cut. MillerKnoll required that the machine work with a variety of materials, including thick vinyls and thin, loose fabrics, which posed a challenge in accounting for different movement behaviors. As shown, some fabric pieces exhibited an upward curl, while others did not. Additionally, different fabrics handled stretching differently, creating an additional source of error. To combat these issues, multiple subassemblies were created, all of which will be described in the following sections. Much like the one currently employed, a roll holding cradle was utilized to hold the fabric up. At the beginning of operation, an operator will manually insert an aluminum bar into the roll and delicately place it onto the cradle. This was selected to keep the heavy fabric rolls at a uniform desired height for loading. A pre-clamp was designed to index the fabric into the machine. The pre-clamp consists of two main components: the pre-cutter clamp itself and the fork plate. The clamp's purpose is to hold onto the fabric at a predictable point during cutting and loading of the next cut to ensure accurate measurements. The clamp could then extend or retract its four SMC cylinders. Small finger bars were adhered to the clamp, gently holding down the loaded fabric to prevent any unwanted curling. The fork plate, as shown in red, was used to raise the cut fabric back up from the cutter height to the gantry clamp height to allow for the fabric to be reloaded. The fork plate includes intentional design cutouts, allowing the clamp to press down on the fabric and pull the piece from the fork plate. The fork plate was controlled by two pneumatic cylinders and slid on two Viva rails. The gantry clamp was designed to clamp the fabric and pull it out to the correct distance. After the fabric was cut, the gantry clamp would pull the fabric off of the cutter before dropping it and returning home for the next cut. The gantry clamp was controlled by a servo-driven belt drive that slid along two Viva rails. Much like the pre-cutter clamp, the gantry clamp was controlled by four SMC cylinders. To combat the problematic curl appearing on already cut fabric, a clamp was created to pin the fabric on the table between cuts. This removed the risk of wandering and the fabric curling over itself. The clamp was driven by two pneumatic cylinders. Shown next is a 4-piece 26-inch sample runoff.